Vera Cooper Rubin, born July 23, 1928, is an American astronomer. Background and education. Vera Rubin's father, Philip Cooper, was an electrical engineer, born in Vilnius, Lithuania as Pesach Kobchefski. Her mother, Rosa Applebaum, originally came from Bessarabia, and worked for Bell Telephone Company calculating mileage for telephone lines. Rubin has an older sister named Ruth Cooper Burg, who was an administrative judge in the United States Department of Defense. Rubin earned her BA degree at Vassar College, and attempted to enroll at Princeton, but never received their graduate catalogue. As women they were not allowed in the graduate astronomy program until 1975. She instead enrolled for her master's degree at Cornell University, where she studied physics under Philip Morrison, Richard Feynman, and Hans Bethe. She completed her study in 1951, during which she made one of the first observations of deviations from the Hubble flow in the motions of galaxies. She argued that galaxies might be rotating around unknown centers, rather than simply moving outwards, as suggested by the Big Bang theory at that time. The presentation of these ideas was not well received. Rubin's doctoral work at Georgetown University was conducted under advisor George Gamow. Her PhD thesis upon graduation in 1954 concluded that galaxies clumped together, rather than being randomly distributed through the universe. The idea that clusters of galaxies existed was not pursued seriously by others until 2 decades later. Scientific work. After her graduation, Rubin taught at Montgomery County Junior College, and also worked at Georgetown University as a research assistant, and in 1962 became an assistant professor there. Also in 1965, she became the first woman allowed to use the instruments at the Palomar Observatory. Prior to this, women had not been authorized to access the facilities. In 1965 she also secured a position at the Department of Terrestrial Magnetism at the Carnegie Institution of Washington, and has worked there as an astronomer since that time. Rubin is currently a senior fellow at the DTM, and her work area is described as galactic and extragalactic dynamics, large-scale structure and dynamics of the universe. Galaxy rotation problem. Rubin began work which was close to the topic of her previously controversial thesis regarding galaxy clusters, with a gifted instrument maker named Kent Ford, making hundreds of observations. The Rubin Ford effect is named after them, and has been the subject of intense discussion ever since it was reported. It describes the way in which the rotational curves of spiral galaxies do not match theoretical curves. Heated debates about their work ensued in the astronomical community, and some astronomers even pleaded with Rubin for her to stop doing this research. Wishing to avoid controversy, Rubin moved her area of research to the study of rotation curves of galaxies, commencing with the Andromeda Galaxy. She pioneered work on galaxy rotation rates, and uncovered the discrepancy between the predicted angular motion of galaxies and the observed motion, by studying galaxy rotation curves. Simply put, galaxies are rotating so fast they should fly apart, but they are not flying apart, therefore, a huge amount of mass must be holding them together. This phenomenon became known as the galaxy rotation problem. Her calculations showed that galaxies must contain at least 10 times as much dark mass as can be accounted for by the visible stars. In short, at least 90% of the mass in galaxies, and therefore in the observable universe, is invisible and unidentified. Attempts to explain the galaxy rotation problem led to the theory of dark matter. Dark matter. In the 1970s, Rubin produced clear observational evidence that finally convinced astronomers worldwide that the vast bulk of the mass in the universe is invisible, and unknown in origin and character. As to what constitutes dark matter, the question is one of the major unsolved mysteries of astronomy today, and many theoretical and observational astronomers are hard at work trying to answer it. The effort to understand dark matter defined much of astronomy for the next 2 decades. Astronomers may not know what dark matter is, but inferring its presence allowed them to pursue in a new way an eternal question: what is the fate of the universe? Currently, the theory of dark matter is the most popular candidate for explaining the galaxy rotation problem. The alternative theory of modified Newtonian dynamics, has little support in the community. Rubin, however, prefers the Mond approach, stating, "If I could have my pick, I would like to learn that Newton's laws must be modified in order to correctly describe gravitational interactions at large distances." That's more appealing than a universe filled with a new kind of subnuclear particle. Personal. Rubin has been married since 1948 to Robert Rubin, whom she met while he was a fellow graduate student at Cornell University majoring in physical chemistry. All four of her children have earned PhDs in the natural sciences or mathematics. David, 1950, PhD Geology, a geologist with the U.S. Geological Survey. Judith Young, 1952, PhD Cosmic Ray Physics, an astronomer at the University of Massachusetts. Carroll, 1956. PhD Mathematics, a mathematician at the University of California at Irvine, and Allen, 1960, PhD Geology, a geologist at Princeton University. Motivated by her own battle to gain credibility as a woman astronomer, Rubin continues to encourage young girls to pursue their dreams of investigating the universe. Overcoming discouraging comments on her choice of study was a constant challenge, but she persevered, supported by her father, and, later, her husband and family. In addition to astronomy, Rubin has been a force for greater recognition of women in the sciences. She has advocated for more women in the National Academy of Sciences, NAS, on review panels, and in academic searches. She says that she has fought with the NAS, but she continues to be dissatisfied with the number of women who are elected each year. She states that it is the saddest part of her life and says, 30 years ago, I thought everything was possible. Of her potential legacy, Rubin remarked, fame is fleeting, my numbers mean more to me than my name. If astronomers are still using my data years from now, that's my greatest compliment. Religious views. Rubin is an observant Jew, and sees no conflict between science and religion. In an interview, she stated, in my own life, my science and my religion are separate. I'm Jewish, and so religion to me is a kind of moral code and a kind of history. I try to do my science in a moral way, and I believe that, ideally, science should be looked upon as something that helps us understand our role in the universe, that helps us understand our role